All right. Well, everyone, today we're going to be talking about the glue benchmark. So let's do that. So I made a few slides on this, and then I'm going to break over to the white papers and some blog posts on the subject.
Nice that you have a naturally loud voice.
So yes, I have a very naturally loud voice, much to many people's annoyance in my life, but there are some bonuses to that. So yes. Okay. So what is glue? Well, glue stands for.
Are you sharing the screen?
Oh, sorry. I thought I was, but I guess I'm not. Okay. All right. Let's see here. All right. There we go. All right. So GLUE stands for General Language Understanding Evaluation. In other words, it sounds like if that's not a backronym, I don't know what was. But anyway, so that's what it stands for. So basically what it is, it's a suite of benchmarks that are designed to understand language evaluation tasks. Okay. So one of the problems that we often have in NLP, particularly if you're doing more like unsupervised learning, is how do we know if our algorithms are doing anything useful, right? And so, so this is a challenge, right? So a lot of our problems that we look at in kind of our toy data sets, we'll do some kind of simple sentiment analysis with some supervised learning problem. But in practice, that becomes difficult to do at kind of with larger data sets. And so we also need some apples to apples way, because for example, let's say we come with this great new and better approach to some problem, say sentiment analysis, for example. But if I go and publish my results, how do I know that, how do other people that are reading my paper know that I really did anything unique or interesting, right? Because I could very well be using, and so one of the challenges is that we all use different data sets by its nature. I mean, different applications are going to use different data sets, but we need some apples to apples way in order to help evaluate that for the purposes of research. And we also, so what we need is we need two things. First of all, we need some benchmarks that we can then say, a way that my score on these various evaluations is some number. And then that number helps us to have an impartial way to help evaluate different people's results. And another thing is we need some kind of standard public data sets, ones that are going to basically be available to anybody and everybody around the world without issue, all that kind of thing. And GLUE also has a leaderboard. So many of you are probably familiar with the Kaggle. So Kaggle, which is a kind of data science website where people can compete to have, for example, the best accuracy or the lowest loss or whatever kind of metrics you want to use on various data sets that they're provided there. So a lot of people do that, right? So in a Kaggle competition, you'll have different teams or different individuals. They have a leaderboard which shows who performed the best in terms of that, right? So probably most of you have seen Kaggle competitions before, right? So GLUE also has a Kaggle style leaderboard. And we can go ahead and take a look at which teams have the best score when it comes to that. Okay, now the original benchmark is actually called GLUE. Now, recently in 2019, there's a publication called SuperGLUE, which is basically a harder benchmark. The motivation being is that the original GLUE benchmark is such that performance overall has improved, and it's harder to differentiate kind of cutting edge algorithms because nowadays par for the course has changed, right? So SuperGLUE is add some additional tasks in order to help kind of move things forward. Now the GLUE white paper here is this. It's actually, I'll bring it up, but this is actually the slide for it. It's a multitask benchmark analysis platform for natural language understanding. So, and you can see, so basically what the authors of this paper did, you can see these authors, what they did basically was they took a bunch of public data sets, they took a bunch of evaluation metrics, and they're trying to create kind of a par for the course here. And so that was the idea that they have. You know, nobody's probably claims that glue is really the be all or even the best of anything. For example, most of the data sets in glue are pretty generic kind of stuff. I mean, of course, the authors had to pick data sets that were relatively short, small, publicly available to everybody around the world without issue, you know, all those kind of things, right? So, you know, again, that doesn't necessarily mean that there's anything special about that data really at all. It just means it's something that anybody, even if they're in some faraway place or whatever, can easily do, and it gives us all kind of a common framework that we can do that. Okay. Now, superglue, of course, is the more recent paper. Now, despite the fact that it's newer, it hasn't necessarily replaced glue by any means, but it also provides an alternative benchmark.
So it's a paper and an implementation.
It's a paper and an implementation, right? So, so that's what superglue. Now, both glue and superglue are fairly new. The glue paper was published in 2018. Superglue was published in 2019. Well, so at the time of recording this video, it's just the very beginning of 2020. So obviously, you know, we're kind of moving forward with this. So, okay. Now, so the glue benchmark does
I
have.
also see the code. That seems to be the code that implements this glue.
We can look at the code as well, right? So,
which means that we could run that on our own server for our own fun.
well, that's the whole idea. Yeah, the idea is that we should be able to go ahead and use the code in order to run that. Now, the idea behind the code is it's more of a testing framework, right? So part of the idea is that it's not intended really to specify one particular implementation, although the testing framework does rely on PyTorch. So there is a dependency there. But you know, there's no reason why one would necessarily need to develop the model in PyTorch per se, right? But
where does the testing actually run? Not on the same website.
of course not. No, it would. You know, the testing benchmark for now. I'm personally unaware of exactly what the mechanics are of submitting one's models, etc., to a leaderboard. What I'm going to assume is that they probably only accept submissions from people who are, you know, relatively serious, and they'll probably go and have some servers available in the cloud that they can run through their benchmark and then get some
What I'm
results,
thinking is
right?
that
So,
when I'm talking,
well,
when I'm talking, I could talk, but no, because then it shows up on yours.
okay. Yeah, if you want to, so that's so that's a general idea. I mean, I'm sure a lot of people use the glue testing suite and benchmarking tools and all that with very little interest in trying to go to the public leaderboard,
Yes,
right? So yeah.
You could try it on your own.
Well, exactly, and I'm sure that the Googles and the Facebook and the other world probably make use of all of that, and probably have maybe some of them may have little interest in terms of that. You know, the thing about glue, of course, is that although it is useful to have a neutral benchmark, it's highly unlikely that the glue data sets or the results are going to be, or the testing is going to be exactly the same as what any one company would want to do. So for example, our company, we have a very specific use case, and the glue data sets and the benchmarks are not really at all focused on that particular use case, nor are they intended to be, right? So part of the idea is that
yesterday that we can test out stuff on the glue.
Right. I mean, it certainly it could be useful to do as a benchmark, and but that doesn't necessarily mean that the glue benchmark performance would necessarily reflect performance on our own corpus or our own use case, right? But it is at least
we run our own.
We run our
That
own.
reflects what we do.
Well, it is true, but again, if we run our own benchmark, then other people will have no idea what we're doing, right? Whereas
That's
everyone
separate
would
for
know
us
about.
to know what we're doing.
Exactly. Yeah, exactly. So you get the idea. But so that's the idea behind glue and what it's about. So now glue has a bunch of public data sets. So actually, you're probably interested to know exactly what these data sets are. So we can kind of go ahead and briefly look at some of those. One other thing about glue is that it's not, one of the things that probably made it unique is that it's designed to be generically around a lot of different kinds of NLU tasks without focusing on any one particular one. So before glue, for example, there were many benchmarks that were around for problems like, say, sentiment analysis, or many benchmarks, say, around named entity recognition or other kind of common NLP tasks, right? Glue actually decided they did, of course, they wanted to include a kind of a broader base of pretty disparate kinds of benchmarks, including both of those things I just mentioned, both entity extraction and sentiment analysis, which are two very dramatically different tasks, right? And one, in fact, might not even use the same model for both tasks because they're just so different, right? So, so one of the things that Glue did is it allowed people, first of all, one could pick and choose what benchmarks that one was interested in, but also it gave a way if one has ambitious goals to try to do a lot of different kinds of, a lot of different kinds of things, right? So let's say you want to do both sentiment analysis and entity recognition. Well, it gives you kind of a more broad-based kind of test suite to do a number of different things. So that's part of the idea behind that. Okay, so let's go ahead. I actually have a few. Things. So actually, in our repo here, by the way, went ahead and added. So if we go to the, we go ahead to Skya. Yes.
Those slides.
I have not added the slides. I have added the script.
Right?
Yes, I will. So we go to Skya, and then we go to our. I'm sorry, it's not Skya. It's under data sets. So in other words, if I just go, let me just go to the GitHub website here. It might be easier to see for the purpose of the video. So if I go to Skya AI, and then we go to data sets. I just recently added a script here under Glue, and it's called download Glue data. All right, so here it is. So this data set here is, I actually adapted this from something on the Glue website. So this script here, when you run this, it will basically just do a simple, there's nothing fancy about it. It's just doing a simple download of all of the Glue data there. And there's
on Google.
Right. This is because these links are provided by Glue themselves, right? So, yes. So basically, what we did is we're just going ahead and downloading those, and then saving them locally. And the Glue data sets are fairly small, so one can, with.
Why did he choose Google, not Amazon? To be.
Who knows? Glue? Who knows? Actually, I believe Glue was. I believe Glue is actually sponsored by several companies. I noticed Facebook is one of their sponsors.
More money.
I don't know if there's some, I don't know what some of the, the business reasons for that would have been, but since the choice, no doubt, of PyTorch as a part of the framework probably had something to do with Facebook sponsorship, and perhaps Facebook has some kind of interest in some things around Google APIs. I mean, who knows? Yeah, so that I don't know. Anyway,
that sounds reasonable.
Yeah, so this is what we have here. So we're downloading the data, and in fact, if we go ahead and run this, so in fact, if you go ahead to Skya Datasets Glue, and you go ahead and I believe the only dependency is just Python standard library stuff. So you should just be able to easily go and run. And go ahead and run this. So if we, in fact, so if you just say Python, download Glue data, etc. Now I've actually already run that. So if I go here to the Glue data, so you notice that each of the data sets is running, right? So, and you can see here that the data sets are there. So for example, this is the COLA data set, which is one of the data sets here. And notice that the data set here is in TSV, and there's tab separated values format, which, basically in Python, we can very easily parse this using pandas or something else, right? So there's a lot of different ways that we can do that. So this, for example, notice that this particular data set here has, some short text that we do. So, you might be interested. So we're probably not, for the purpose of the video, going to go to every single one of the data sets and try to look into it. But let's just go ahead and look at that particular one, which is the COLA data set. Okay, so the COLA data set is the corpus of linguistic acceptability. So, and so what you can see here is that So in this case, so you can see here what this is that is essentially going to take some sentences where they're going to be annotated for acceptability. In other words, is it grammatically and semantically correct in terms of that as a as in other words, is the idea here is that would your middle school English teacher approve of this sentence or not, right? So so there we go. You know, so that's the idea. So again, this is a particular problem that is there. One of the data sets that we have here, right? And so that's one of the suites there. Okay. So
there are 11 blue tasks, right?
Right. That's right.
Are we saying that each of the proposed model must also have an implementation to resolve exactly each one of the tasks?
Not necessarily. I mean, one can treat it as if it's more of a menu that one can just choose the data set task that you want to do.
What you do, but
right. So
those submissions, they have score on everyone.
Well, yeah. So if I don't know exactly the mechanics of a leaderboard, but if one was wanted to publicly submit but was not interested in one or more of the glue tasks, then one would just get a 0 in those tasks, and that might be fine for your application, right? You may not be interested.
I don't know.
Well, maybe not on the public leaderboard, but one could say that for this particular task, we got this particular score, right? And so I think that would probably be fine.
Presumably they have different leaderboards for the different tests and data sets.
They do.
Right?
They do. In fact, if we go to that, right? So if we go to Glue Bench, I don't think that they, again, the leaderboard is kind of nice, but I don't think that it's necessarily something that people, spend. People probably don't go to cocktail parties like, kind of bragging about their scores on Glue, right? So, well, maybe they do. Yeah. So I don't know. I don't know.
It's like I saw recently the Erdős distance. Paul Erdős, the mathematician. So how far are you away from working with things that? And that guy, this German guy whom we heard yesterday, Warburg, no, that was his name.
Well, I don't remember actually.
So his Erdős score is 4.
Okay.
And then Bill Gates' Erdős score is also 4.
Oh, okay. Well,
interesting fact. So,
well, does that say more about him or more about Bill Gates? That's the question.
Know.
So,
so you may be proposing your score.
So here's, for example, so according to the bragging rights of the superglue lead, now this is superglue, not glue, but according to the bragging rights of the superglue leaderboard, we have the T5 team at Google, which is currently has the highest score on various tasks. Although, for example, the one we just saw, the Cola, apparently the Ernie team from Baidu, which is a Chinese, kind of Chinese company who does search, they have a higher score on that particular task, the Cola task, right? So
Alice model has even higher score on that.
Right.
So,
right. So
okay. So it is broken down.
It is broken down. You can see here, right? So it's kind of interesting. You can see that that a number of the BERT variants seem to be very prominently mentioned here. Things like, for example, we see Ernie, which is of course a very is inspired by, we say, BERT, right, as well as Roberta and others. This is super glue. We can actually go to the leaderboard for glue as well. Well, I actually just brought that one up, but we can go ahead and do the we can also go ahead and do the original glue benchmark as well. I believe it's gluebenchmark.org actually. Gluebenchmark.org.
So the only difference between, I guess, glue and squad is this is like a multitask.
That's exactly right. Yeah. In fact, actually, the squad data set, the question answer data set, that, although I don't know if it's the full data set, but there is a data set within the glue benchmark which is based on the very same squad data set, right? So there, let me go to the glue bench.
So glue's a better benchmark?
It's not necessarily better, but it's more comprehensive, right? So if one was only going to be focused on simply question answering and nothing else, then you may not necessarily be interested in glue per se, because you might just use the squad 2.0 data set for that. But glue gives you kind of a more comprehensive data set that one can use if that matters, right? So Okay, so actually, I was still looking for the. Let's see. This is yeah. So here's this is actually so. There we go. All right. So. All right. So actually, I was showing you the glue benchmark. I'm sorry. The super glue benchmark is here. Right. Okay. Yeah. All right. Right. So I'm sorry. It's a little bit confused on there. All right. Yeah. So you can see here. This is the super glue benchmark, and the T5 team from Google actually is the best. I believe is the best. Now notice here that the top team from Superglue is actually it's a human baseline. So that's actually not a model. That's basically a par for the course generated by human annotators. So so T5 team from Google here actually is still actually on top of all the AI models here. So there's something to be said for that, right? So that's what we have here. Yeah, so let's kind of look at a little bit at about how. So I showed you I did actually look at this script and we download this. Now, what about kind of automate? So let's say we wanted to use. We all believe in testing, right? It's the greatest thing. Your testing is. Somebody said doing proper testing is a lot like flossing your teeth. You know, we all agree that it's a great thing to do. Actually, doing it may be a different thing, but we all agree. No one would deny that flossing your teeth is good, much like testing. Yeah. So as a testing model, it may prove to be useful for us to try to adopt. We don't necessarily have to adopt Glue wholesale. We don't necessarily need to do that, but having some kind of testing strategy is no doubt a good idea. Now, Glue also has a, in addition to having that, they have a open source kind of framework that they have for doing plugging in and running of Glue for things like testing and regression testing and that kind of thing. So let me see, I have this up. Let me see where it is. Hang on. So actually, well, before we get to that framework, actually, there was a nice blog post I had, which I think would be which would be good to go through as well as part of our presentation. So let me go ahead and get that. I have this up somewhere. Where is it? Okay. Where is it? Excuse me. Here we go.
Baidu claimed that they're better on every one of those tests for Chinese. I'm wondering that is still.
Well, I don't doubt it. I mean, again, the thing about any kind of task, of course, the Glue benchmark is entirely with English texts, and it's also with one criticism that you could make of it. Although this is just would be true of any benchmark, is the fact that it's just very. It is a very it's done on a certain type of data, which happens to be all in English, happens to be this, happens to be that, right? So I don't doubt that Baidu. I imagine they probably have some of their own internal benchmarks and tests that they do for Chinese language data, and I also wouldn't doubt that their models for that may be somewhat different, right? Because it's whatever you're doing for your work on Glue in English on the tiny text it is you might have a different.
So do you feel that doing internally for us, for example, is doable? Feasible?
It's definitely feasible. I think, in fact, now on the other hand, well, I'm going to look a little bit at. Oh, I think the most useful part of Glue for us might be some of its instrumentation framework, right? Because we want and need the idea of having kind of automated, benchmarking and testing, even if we don't necessarily use the exact same Glue data sets and the exact same benchmarks, right?
I was always saying we will have something like Glue. You're telling me we'll have Glue itself, not something.
Well, no, actually, the framework that I'm going to show you is not actually Glue per se, but it is closely related, right? Glue is the test suite, and then of course Glue, as in terms of in order to implement the Glue test suite, they also have testing frameworks that are designed to help that, but they wouldn't necessarily have to be used together, strictly speaking, right? One could kind of pick parts of Glue that you liked and only run those. You could add your own test. You see what I'm saying, right? So, all right. So here actually is a blog post which kind of talks again more about what kinds of tasks. So again, I'm not going to go through all this. Some of this guy that writes this blog post, I guess I should give credit here, Chris McCormick and Nick Ryan. So
you did a really good job. Is that on the slides?
well, the slides are pretty Spartan so far, but
For example, like this thing.
he's not there now, but I can certainly add it. Yeah. So
I'm thinking about that. If we're recording, if we're doing this, and if you have a complete slide deck, not the perfect 3 slides.
Okay. Yeah.
To go with that, wow, that is a complete thing.
Right.
You can re-listen to your favorite teacher. That's you.
Oh, that's my favorite. Am I your favorite teacher?
Yeah.
Okay. Well, thank you. That's very kind of you. Okay. So it's talking about here, right, that, again, that there's a lot of different NLP tasks. So he's talking about things like named entity recognition, co-reference resolution, other kinds of problems there. And these are related but distinct tasks, right? So that's what their point is. And the idea is that, having to have a, so it talks about here about kind of, do we want to have very highly specialized architectures, which are designed solely to do one particular task, kind of do one thing and do it well principle? Or do we want to see if we can have transfer learning potential where we can take maybe portions of our NLP models, which we can use as reusable blocks, which may not necessarily be specialized entirely for one particular task. Of course, ultimately, a model for question answering would have, in some ways, have to be different than a model for co-reference resolution, right? Because they're 2 different problems. But since they are, well, somewhat related, then the idea is that could we use transfer learning here to take, some portion of our, in this case, we have our input text to try to get some output prediction. Could we take this as a transfer learning module that we could then use in another NLP-related neural network, which might be focused on a totally different problem, right? Obviously, we would probably have to, fine tune. We have to do all of that. But the idea is that can we do that? And so that part of the idea behind the GLUE benchmark is to give us a way to have a.
He talks about what's the total score. It's just the sum of all of them.
Right. Exactly. Yeah.
Average, in other words.
Well, this is showing sigma, but there may be some kind of right. So it could be some kind of it could be some kind of average of that. So okay.
So it's a very complicated thing how they calculate this. It's almost a neural network.
Well, no, it's just there's just, there's
make a neural network just like that.
All right. So the tasks here, we have here. They actually provide this link here that you can see that provides what are the links to the tasks. So we already talked about the COLA, linguistic acceptability task, right? And they have, a paper for that, a metric or whatever. There are different other ones. For example, we have a sentiment analysis problem here. We have textual similarity problems, which is something probably interesting for us here from what we're doing. We have question answer pairs, kind of other things as well, and including somebody, William here asked about the squad data set, right? Well, actually, this squad data set is, although not identical, it is. We have a data set here that's based on the squad data set. So that's what that comes from, right? So we won't go ahead and do all of the examples here because there's quite a few, but just to give you kind of an idea of what we have, right? So that gives us kind of what we have. So in terms of what are our models, and the leaderboard there, both GLUE and SuperGLUE has a human annotated baseline here. The human annotated baseline basically is just what a bunch of humans did in order to manually hand annotate the results as a kind of par for the course, right? So currently, it looks like in GLUE, the AI models are outperforming the human baselines. And
in SuperGLUE, the humans were.
SuperGLUE, the humans are on top. So he actually asked the natural question, one might say, is that, well, if the human annotators are there then well, how could the computer ever actually outperform them? Because in a supervised machine learning problem, one would assume that the human annotation is used as a label to manage performance, but that's not necessarily true, actually. And actually, it mentions here that human annotation might be imperfect to some degree, right? And so there's some ambiguity with that might be, with
like the testing yourself on this will teach you that you don't measure the weakest algorithm.
Yeah, that's right. Well, potentially one of the reasons why superglue is been kind of moving forward as a task is that there's more room for models to improve, because we see now that the human annotation is still the top of the leaderboard there, right? So
what's funny is that meeting ends in 10 minutes. I was thinking, should we set a limit or no? There's
10 minutes is probably fine.
Yes, yeah.
So
there's an automatic limit
it stops us from doing it too much, right? Now they also mention here that so we also mention here, so we have the glue data, how these are tested on glue, so you can see if we can fine tune that. So that is a reasonable good article. Now, since we're limited on time, I also want to point out that glue themselves, or I wouldn't say glue, not but they're related to glue, is a GitHub public and open source framework that one could use, that we could use in order to let me see, I got a bunch of tabs here. Let's see if I can that we can use for that we could use for our own purposes, right? In fact, actually, the glue benchmark actually originally had some kind of scripts and other things that they had provided here, but they've since actually used this framework called Giant instead. Okay, so this Giant is actually designed to be a more generic software toolkit used for researchers in NLP, not necessarily directly focused on glue and superglue, but although it does include implementations of the glue and superglue frameworks there. So I kind of recommend that we take a good look at this Giant framework, because it can help us in terms of running through running through a bunch of tests that might be useful for us as well. So anyway, this is called Giant with a J, like this, right? So that's the framework here, and it is the glue. If you look at the glue code themselves, they've kind of deprecated their original set of code that they had on their website in favor of this more generic Giant toolkit, right? So anyway, so that's that. All right, well, so I know our meeting's going to run out, so you guys have any questions before we end the presentation? Okay.
No, it's good. I like the way you formatted it.
Oh, okay. Well, actually, to be honest, I only had like 5 slides, so obviously I could definitely improve that. But it was what it is. Yeah. So.
It is informal.
Yeah. Okay. Anyway.
So I guess it's kind of an open-ended question, but I mean, which of these kind of tasks do you see us actually kind of trying to implement or testing?
Well, one thing, the semantic similarity, I think, would be very interesting for us, right? Because, in fact, one of the criticisms that our self-criticisms we have of our similarity model is we're using like cosine and Jacquard, which are fairly naive kind of similarity models to start with, right? And we're trying to measure similarity. One of the challenges we had back when, we were working on the earlier version of that is that we had difficulty really evaluating that with the semantic similarity part, because semantic similarity is basically an unsupervised machine learning task anyway, right? So we were just, all we were doing, frankly, is we were just making sure that we were selecting the same document that we should have thought of done in the first place, right? Where there's an obvious weakness in that in terms of really giving a fair, kind of fair and valid benchmark. In fact, I'd say in our previous approach that we're doing, that was probably the biggest weakness to our approach, is the evaluation model we were doing. We were doing precision and recall, but the precision and recall was not a really, we had data leakage more or less because the whole methodology was kind of, was kind of really flawed, frankly. I mean, it was okay for the very rough sort of demo that we were doing, but the precision recall numbers that we have, I never took them very seriously, and so I think probably the most useful thing for us in terms of that would be to look at the semantic similarity data set, because now we have a nice annotated semantic similarity data set that we could use, BERT encode it, then look at that and see whether our similarity model is really generating something results that are there that gives us at least an objective measurement of that. So I think that
previously our approach was, so we BERT embedded, right, and then we did
like cosine and Jacquard similarity of the resulted vector, right?
We did like a natural neighbor. You did natural neighbors?
I'm sorry?
Nearest neighbor?
We did NN, nearest neighbor.
Okay,
yeah. So we did NN, nearest neighbor, with cosine or Jacquard similarity, right? So that approach actually is fairly naive, although actually for example, a lot of recommender algorithms do exactly that, right? So in other words, if you're want to find more, more like this with like music and stuff, I mean, a lot of recommender algorithms do exactly that kind of approach. Vectorize them, use near.
The same question.
So
we don't have fine tuning. We don't have that lesson layer.
Right, and that's why
labs would do.
Yes.
But here
that's because our labs are supervised problems, and this is an unsupervised problem.
So could we do better? That was one question. No answers yet.
Because we were having those embeddings, but the semantic, I guess, relationships aren't really built into that.
Another question. When users start using our system, that is supervised feedback.
True.
Today, we're not even thinking about
That's one way in terms of data collection we could get supervised feedback for sure. Right? So in a lot of ways, actually, our problem, that, as we've described it so far, is actually in some ways a recommendations problem, right? And so the types of mechanism in terms of our use, we should think similar to a kind of like a iTunes music store kind of use case, right? I say iTunes music store because we're not like a Netflix, because we're not going to be getting our users like giving 5-star ratings, but think more like a iTunes music store kind of use case where you're trying to intelligently kind of anticipate what the user wants, right? Without the user applying explicit feedback, right?
We might have nice people doing the ratings. We need to accept any kind of feedback.
Well,
whatever form.
True, that's true, but of course, so in that way, like one of the big problems with recommendations is just the implicit versus explicit feedback, right? And so in some ways, some of our type of similarity is going to be kind of a similar in that way, right? So and similar in the sense, just like recommendations, that many times in practice it has to be more of unsupervised learning, or at least semi-supervised, because in practice, people are too lazy to give you explicit feedback, right? So, so you have to infer that based on different things.
I think that's something we kind of talked about briefly before, is like if you could even implement something like a thumbs up, this is what I was looking for.
Well,
thumbs down, this is not what I was looking for.
That kind of thing is definitely a challenge for anything, which companies always are trying their best to try to engineer, kind of social engineer ways to get you to provide explicit feedback.
But if he uses your result, that is thumbs up.
Right.
Well,
if they immediately search for something else, that's
like the Everybody Lies book. One of their big points is that basically watching what people do is usually more useful than listening to what they say.
Yes.
Right. And so.
So in the search result,